Hello everyone. In this video we're going to be going over how we can use algebra tiles to help us visualize multiplying two monomials together or multiplying a monomial with a binomial. Remember, monomials are just polynomials with one term, binomials have two terms. And then we're also going to be learning how we can use algebra tiles to divide polynomial problems. And learning how to do this process with algebra tiles can definitely be helpful for people that like to learn visually. However, even if you don't, it's still a good skill to have because you will sometimes see problems like this on quizzes or tests or exams. So let's start off by going over some terminology here. Remember that when we multiply two numbers together to get a product, we call those two things being multiplied together the factors. Product is just a fancy word for the answer to a multiplication problem. Now, when we set up a grid here to visually multiply two things together, we set it up with two lines, a horizontal and a vertical line here. And the two factors, the two things we're multiplying, we draw one across the top here and one along the left side. And then what we draw in the middle becomes the product. At this point, that might be kind of confusing, but once we do some examples, it'll make a lot more sense. And before we get into doing this with polynomials, let me show you how this can be done for a very basic multiplication problem. Let's say we were multiplying 2 times 3. So that we have a factor of 2, a factor of 3. We, of course, would get 6. If we wanted to show this visually, think of it as like two groups of 3. So here are my two factors. That represents 2. This represents 3. And what belongs inside? If we fill this in, let me change colors here. We have 1, 2, 3, 4, 5, 6. So 2 times 3 equals 6. Now let's try applying this to some polynomial problems. In our first example here, we're multiplying x times 2. So the nice thing about this is you can actually choose where you want to draw the x. Whether it's across the top, you could draw it like this. Or if you wanted to, you could draw it down like this. It doesn't really matter. You'd get the same answer either way. So I'm just going to have x drawn across the top here. And remember, x is represented by a rectangular bar like this. And I'm shading it in to show that it's positive. Now, since I'm multiplying it by 2, I'm going to draw two small squares along the other side. And I'm shading it in because it's positive. Now, what I've done is I've drawn some dotted lines here to kind of show you almost like an invisible grid to help you figure out what belongs here on the inside. And you can see that in order to fill in these sections inside here, I need two bars. And I know I'm going to be shading them in because I know a positive number or something positive times something positive is going to give me something positive. So what this tells me is that x times 2 equals 2x. So let's write that out. X times 2 equals 2x. All right, let's try another one. Now we're multiplying x times 2x. So let's go ahead and, you know what, I'm going to draw my two x bars across the top here, which means I need to draw a single x bar going down this way. And by the way, notice that I'm always drawing these x bars across the top flat, horizontally, and then this one along the left-hand side, I'm always drawing up, down, upright. And that's just the proper way of drawing these. Okay, so let's go ahead and imagine another grid here. Okay, so it's going to go like this and like this. So hopefully, again, this helps you kind of visualize what belongs inside here. Well, we have to draw a giant big square to fill in this gap. And then the other gap is going to be exactly the same thing, another giant square. So visually, this is telling us that x multiplied by 2x is 2x squared. Because remember, these giant boxes, these giant squares represent x squared. And because there's two of them, well, that means the product here is 2x squared. All right, now let's move on to the next example. Here we've got 2x multiplied by negative 3x. So this time, I'm going to draw my two x bars going down on the side here. And then I'm going to draw 3 negative x's across the top. Now, the only difference here with them being negative is that we're not going to shade them in. Now let's go ahead and visualize our grid. And you can see in order for me to fill in these empty grid spaces, we need to draw more big x squared shapes, just like this. There's 1, 2, 3, 4, 5, 6. And by the way, that makes sense because x times x we know is x squared. Now the question is, should I shade these in or not? Well, remember that anytime you multiply a positive and a negative thing together, you're always going to get a negative answer. So because of that, we're not going to shade these in. So what is the answer here? What does this represent? Well, this represents 6 negative x squared. So in other words, negative 6x squared. All right, moving on to the last example here. We've got 2x multiplied by 3x minus 2. So now we have a monomial being multiplied by a binomial. So I've got my 2x down the side here. And then let's draw our 3x minus 2. So 3x, they're all positive. 1, 2, 3. Now we also have to draw in this minus 2 part. Remember, we use small squares to represent constants. And because it's minus 2, think of it as negative 2. So I'm not going to shade in those two shapes. And then after creating my grid here, it becomes a bit more obvious of what is missing. So here we have to draw in 6 large squares. So that's going to represent 6x squared. And remember, positive times a positive is going to be positive. So these all need to be shaded in. And then you'll notice that these big squares don't fit in these other two spaces on the right here. In fact, what belongs here are some bars. 4 of them, actually. 1, 2, 3, 4. Do we shade them in? No, because we're multiplying a positive and a negative together. So what is our product here? Well, we have 6x squared, and then we have 4 of these negative x's. So we rewrite that as minus 4x. Okay, so that is how we can use algebra tiles to help us visualize multiplying polynomials together. Now let's try out some problems that involve division. And remember that division is really just multiplication backwards. It's the opposite operation. So what's kind of cool about this is it's almost very similar to what we just practiced, but working backwards. So a good first step in questions like this is to start by drawing the denominator on the side. So in this first example, we're dividing by x. So I'm going to draw my x tile along the side here, and I'm shading it in because it's positive. Step 2 is to draw the numerator on the inside. Now when we're drawing 2x squared plus x on the inside here, you got to be careful that you can't just draw things anywhere in the world you want. Like, I'm not going to draw 2x squared like this and then an x over here. You know, it has to be organized like in a grid. Okay. Not only that, but it all needs to match based on your denominator, right? We have an x bar on the side here, which means everything needs to fit alongside it. So we've got a single x squared, we draw another x squared, and then we draw another x, just like this. Okay, so let's go ahead and finish off that grid here. And then now we can kind of see more easily what's missing along the top, because that's going to tell us the quotient here. Remember, quotient is just a fancy word for the answer to a division problem. So we gotta work backwards here. X times what is x squared? Well, that's x. So we're drawing x bar here. In fact, we would draw another x bar right next to it. And then in the last spot here, just right here, we need to think x times what is x? Well, that's just 1, right? X times 1 is x. So that's it. So what this tells us is that the quotient here, represented by what we just drew across the top here, is 2x plus 1. Let's try another one here. We have negative 4x squared minus 4x over 2x. So we're going to start by drawing 2x on the side here. Okay, now let's go ahead and start drawing our grid in. I know I'm going to have to draw lines going across like this. Next, we're going to draw our numerator, negative 4x squared minus 4x, on the inside. But we have to do this very carefully. Since we're dividing by 2x, you can see that we need to actually divide our numerator into 2 equal parts. So instead of drawing 4 negative x squareds across the top like this, That's not going to work. We want it to divide it equally across the top and bottom. Of course, half of 4 is just 2. So we want to actually just draw 2 in the top section and 2 in the bottom section. Same thing is going to happen with our negative 4x or minus 4x. We're not going to want to draw 4 across the top here. We want to split it equally, so we have 2 in the top and 2 in the bottom. And notice that I'm not shading in any of these because all of my x squareds are negative, and same with the x's. All right, let's go ahead and finish drawing my grid here just to help me out, figure out what the quotient is going to be. All right, let me just zoom in a little bit here. All right, let's figure out what's missing here. X times something is negative x squared. Well, that's negative x. And in fact, that makes sense because I know that there should be a bar here to make this shape make sense. So x times negative x is negative x squared. We're going to draw the same thing in this space. All right, next we need to think about x times what is negative x. Well, that's just negative 1. So I draw a negative 1 here and another negative 1 here. And that's it. That tells us our quotient, what I'm circling in red here, is negative 2x minus 2. All right, we're going to wrap up the video with one last type of problem here. In this question, it says to determine the division statement based on this drawing. The dark tiles are positive. What is the quotient? Okay, well, remember that what's on the inside here represents the numerator. So we have negative x squared, negative x squared, negative x squared. So there's 3 of them, right? So we know that we have negative 3x squared. And then how many of these x bars do we have? 1, 2, 3, well, 15 of them. And they're all positive. So we're going to be adding 15x. That's our numerator. We're going to be dividing by what's on the left side here, which is negative 3x. So that's the first part of our division statement. To find our quotient, let's zoom in a little bit here. Let's think about what's missing across the top. Well, we need to draw a bar here because I know that x times x is x squared. However, this is a negative x. This is a negative x squared. This needs to be a positive x. So I'm actually going to shade it in for this to work out because I know that a negative times a positive is a negative. And then over here, we're going to have to draw in 5 small squares. This time I'm not going to shade them in because I know a negative times a negative gets me a positive. So what does this represent? Well, this represents x, a positive x, minus 5. So to finish off our division statement here, this equals x minus 5. So this is our entire division statement. It's got the numerator, the denominator, and the quotient. And just one last note before we wrap up this video, you'll notice that you know in questions like this, you don't have to draw those grid lines like I've been doing. I was just doing that to show you and help you visualize how to do this. But when you do these problems yourself, as you can see, drawing those grid lines isn't actually necessary if you don't want to.